This is Earth, 335 million years ago. I wasn't around then, but there's just one supercontinent, Pangaea. See? Let's watch it shift around and fast forward. Okay, here we go. It just split into two huge pieces. Australia goes this way, North and South America go that way. Africa, Asia, Europe, forming, and there we go. The planet as it is today. Let's keep going. I mean, the continents are always on the move. Over time, some of them will crash into each other. Others will break apart. But that'll take about 100 million years. Better put it on super fast forward. 100 years from now, humans keep spitting carbon dioxide into the atmosphere, and the planet's already warmed up a bunch. The world's ocean levels have risen about 4 feet. The Bahamas? They've totally disappeared. 200 years from now, the Earth's population is about 19 billion people. The climate's gotten even warmer. We're packed in like sardines over here. New medical tech makes it possible to live to 180. But why? Fossil fuel reserves of oil and gas? Long gone. Oh, and the continents have drifted over 16 feet. The Voyager 1 space probe's about to enter an asteroid cloud at the edge of the solar system. It's the most distant man-made object in the universe, I guess. 1,000 years from now, thanks to better quality food, humans are now 7 feet tall on average. Technology solved the pollution and fuel shortage problem. Humanity's doing just fine. Robots do all the work, we just play around all day. Ocean levels have crept up another 10 feet. Islands like the Seychelles, Maldives, Galapagos, and many others have gone underwater. Denmark, the Netherlands, Eastern England, Thailand, and Vietnam are only partially underwater. There's been a huge human migration these last 100 years. Fast forward about 5,000 more years, and it's the year 8113. Humanity's getting ready to open the crypt of civilization. It's a hermetically sealed room in Georgia, in the States. Bad Georgia. It was created in 1940, and it's full of about 800 books on microfilm, recordings of famous people's voices. It's also filled with bits of technology from that time, like a toaster, a radio, and a typewriter. Some awesome people created the crypt of civilization in case humans experienced a major catastrophe in the distant future and had to rebuild civilization from scratch. We'd all go back to using typewriters. 15,000 years from now, our planet has changed its tilt, and the Sahara Desert is now a tropical paradise. Years of rain turn the dry desert into a wild jungle. 30,000 years from now, the Voyager 1 space probe has finally left the asteroid cloud at the edge of our solar system. If it doesn't collide with anything, it'll be flying in the dark, wide-open outer space for a very long time. 50,000 years from now, the climate's changing a lot. The temperature on Earth is beginning to drop, and we are approaching the beginning of a new ice age. The radio signal with a special "Hello, all you aliens out there" message sent into space in 1974 has reached its destination. The message contained the human number system and data about our DNA and our solar system. If there was someone on the other end to receive this signal, we might have a response from them. 100,000 years from now, one of the largest known stars in our galaxy, Canis Majoris, explodes with enormous force. The explosion of this supernova can be seen from Earth, even during the day, and the nights are much brighter because of the new strong glow in the night sky. What's new on Earth? Supervolcanoes start erupting all over. These volcanoes spew colossal amounts of lava and ash everywhere. Thick black clouds cover most of the sky. This prevents the sun's rays from reaching the ground, and the temperature on our planet drops even lower. Humans mostly live underground anyway, so it's no big deal. Because the stars are gradually moving in different directions, the usual constellations are starting to change shape. Soon, we'll need to come up with totally new constellation names. 250 years from now. Oh, a new island's on the map. Back in 2021, it was just an underwater volcano somewhere in the Pacific. After thousands of years of spouting out lava, it finally reached the ocean surface and busted out in the cool, fresh air. Not much growing on it yet. Niagara Falls has long since disappeared, and Lake Erie and Lake Ontario have teamed up to form one huge super lake. 300,000 years from now, the triple star system WR104 is about to explode. It's spinning crazy fast, and there's a chance that radiation from the explosion could eventually reach Earth. That would do a lot of damage to all life on our planet. Voyager 1 reaches the brightest star in the night sky, Sirius. Not a very funny star at all, it's really Sirius. It's 8.6 light-years from Earth. 500,000 years from now, scientists are pretty sure that a huge meteorite could fall to Earth any day now. It might be even the size of 8 football fields. The impact of such a massive meteorite would cause an explosion so powerful that its sound would be heard on every continent. That would be followed by super strong earthquakes and tsunamis higher than the Brightside Empire municipal building tower thingy. Okay, I just made that up, but who knows what we'll be building in the future. 1 million years from now, the rogue star Gliese 710 comes very close to our solar system. We're surrounded by a huge shield of asteroids called the Oort cloud, and the rogue star is beginning to affect the asteroids hanging out in there. It grabs them, spins them around, and throws them toward the center of our solar system. Comets start to fall on our planet all the time, big ones, causing more tsunamis and earthquakes. 10 million years from now, the Red Sea is gradually expanding into the East African Rift. Africa is now divided in two by a new oceanic gulf. The human DNA molecule has completely decomposed. But it's no big deal. We've become totally digital, without any pesky aging problems. The really cool thing is that other animals have evolved a lot and changed ridiculously. Thanks to a simple interface, we're actually able to talk to dolphins, chimps, dogs, and cats. Turns out cats aren't grumpy, they're just busy contemplating life. 25 million years from now. The San Andreas Fault has been crazy recently and has caused the Gulf of California to flood the Central Valley. There's a new sea on the west coast of North America. 50 million years from now, Africa just collided with Eurasia. The Mediterranean Sea is totally gone. There's a new tallest mountain in the world. Its name? Mount Everest, of course. Australia is continuing its journey north. It already collided with Southeast Asia a few million years ago. The few human colonies still left on Mars need to do some serious packing. Phobos, one of Mars' moons, is beginning to orbit at a lower and lower altitude. That's not good. It's about 14 miles wide, so that's going to be unpleasant. 60 million years from now, the Canadian Rocky Mountains have completely eroded. It's just one gigantic flat plain. 80 million years from now, all that remains of Hawaii is one island. All the others have long since gone underwater. But just next door, a whole new chain of Hawaiian islands has emerged. Finally, 100 million years from now, we made it! The Atlantic shrinking down to nothing. The Americas are almost rubbing up against Africa. Africa's already merged with Eurasia. We've got ourselves a supercontinent again. Hello, Pangaea Proxima. All traces of human life are gone or buried deep underground. The movement of the continents has destroyed tunnels, roads, buildings, bridges. Animals and plants now reign supreme on Earth. So, where are all the humans? Well, remember we made the jump to digital about 90 million years ago? Things are still going strong. There are trillions of human minds living on a huge hard drive on a spaceship orbiting Earth. The super low space temperature is good for keeping the drive nice and cool. We have millions of different societies, languages, and cultures, just like we had 100 million years ago. The only difference? We're all little ones and zeros in a huge digital universe that we created. And yes, there's still football. Humanity will once again visit the moon. The mission is planned for 2024. In this crew, we'll see the first women step on the moon. The main goal is to establish a lunar base for continued research that will help NASA prepare for an upcoming mission to Mars. Has been planning a crewed flight to the Red Planet set for the 2030s. Robotic rovers did a good job exploring the Martian surface, But astronauts will have to dig deeper to find evidence of water and any fossils proving microscopic life was once possible on our planetary neighbor. New data on Earth-like planets. Since its launch in 2009, the Kepler Space Telescope has discovered lots of exoplanets orbiting distant stars. Some of them have an Earth-like mass, composition, and orbits. NASA plans to launch a new generation of telescopes in the 2040s. They'll help us find real twins of our planet and even get pictures of their surfaces. The return of Halley's Comet. It'll be another 41 years before we once again see the most famous comet in the sky. Halley's visits us every 75 years, so some will manage to see it twice in their lifetime. The longest solar eclipse. 166 years from now, I'll still be around then, the sun will go dark for 7 minutes and 29 seconds. This is pretty close to the predicted maximum. It'll also be the longest eclipse human civilization has ever witnessed in its 10,000 years. Arrival of the most notorious asteroid. 1950 DA was once the most probable candidate among near-Earth objects we know to actually strike the planet. Fortunately, the chance was later estimated to be not even 0.1%. It'll most likely pass by on March 16, 2880. Mark your calendars. And it'll become a solid evidence that we're safe for a while. The asteroid is more than a mile in diameter, enough to take out life on a planet. A new North Star? The Earth spins like a top. Watch one of these toys closely, and you'll see how its tip starts to draw circles in the air. The Earth's axis, an imaginary line going through the poles, goes full circle once every 26,000 years. It points at different stars along the way, thus changing the North Star. By the year 3000, the Gamma Cephei star will share this title with Polaris, as the Earth's axis will point right between them. The first near-Earth supernova. Antares is the 15th brightest star in the night skies. It's also an old red supergiant, 12 times larger than the Sun. Stars this massive age to a point where they collapse in on themselves, producing huge supernovas. For Antares, this will happen just 10,000 years from now, which is nothing for a 12-million-year-old star. The resulting burst will be too far away to affect life on this planet negatively. But the light show will be visible here on Earth even during the day. Message to the universe. Delivered. Arecibo is the encoded message describing humanity, life on Earth, and the advancement of our scientific knowledge. It was broadcast from the Arecibo radio telescope and aimed at the center of the M13 cluster, 25,000 light-years away from us. In 25,000 years, it'll finally reach its destination. A new closest star. About 36,000 years from now, the Ross 248 star will become our new closest neighbor. It'll be just 3 light-years away from us and overtake the title from Proxima Centauri, which is a bit more than 4 light-years away. Ross 248 will remain the nearest star for around 9,000 years and then move away once again. So, you didn't like the neighborhood or what? The first interstellar human-made object. In 40,000 years, Voyager 1 will reach a point within 1.5 light-years of the Gliese 445 star. It successfully reached interstellar space in 2013. But, unfortunately, it won't be able to power up any of its systems somewhere beyond the year 2025. Voyager 1 has a message too, a recording of greetings in 55 languages, music from classical to rock and roll, and sounds of the Earth's wildlife. A bare Saturn. 100,000 years from now, Saturn will lose its beautiful rings. It'll happen gradually over time as the planet's colossal gravity pulls rocks and ice from this belt floating around it. They'll all eventually fall and get crushed and burned by Saturn's atmosphere. Well, how rude. The ring system is in the middle of its life cycle, so we're incredibly lucky we got to see it in its full glory. The most frightening supernova. The WR 104 star will burst into a supernova in 3,000 years. This star is 75,000 light-years away from us, and the blast won't touch us at all. But there is a small chance it'll also produce a gamma-ray burst in the process. If this stream of energy happens to aim right at us, it will negatively affect life on Earth. Good news? Scientists say that's very unlikely. Colliding moons. The moons of Uranus are part of a highly unstable system. Some of them have orbits that cross paths. Uranus already has 2 rings of debris from past collisions of its natural satellites. Desdemona and Cressida will crash into each other in the next million years and produce new rings. A star too close for comfort. The rogue Gliese 710 star is approaching our solar system, and it will get just 1 light-year away in 1.3 million years. This won't have a major impact on the planets, but it could disturb the so-called Oort cloud, which surrounds our solar system and is full of comets. From Earth, the star will look like the brightest planets we see now, and we'll see many more comets in the skies. The closest star to ever go supernova. Within a few million years, the Spica star, which is only 240 light-years from us, will burst into a supernova. Supernovae are a problem for life when they're 3 times closer than that, but the supernova itself will shine in the Earth's skies as bright as a full moon. A time capsule for future generations. The Lagios 1 satellite was launched back in 1976 to gather information about the exact shape of the Earth and tectonic plate movement. But it also contained information about civilization on Earth at the time. It'll re-enter our atmosphere in 8.4 million years. If humanity is around then, they'll learn how life on Earth was in our time. Well, at least how it was some 40 years ago. Rings for Mars. Mars' moon, Phobos, orbits really close to the surface, and it continues to get 2 feet closer every century. 50 million years from now, it'll collide with Mars, resulting in a massive amount of debris going into orbit and forming a ring system around the red planet. Oh, can't wait for that. Days on Earth will get longer. No, really? 1.4 billion years ago, the Moon was much closer to our planet. It made the Earth rotate faster, so the day was only 18 hours. The Moon is continuously moving away from Earth. In 180 million years, we'll gain 1 extra hour. In a little over 2 billion years, a day on Earth will be 36 hours long. No more solar eclipses. 600 million years into the future, the Moon will move away from the Earth too far to cover the Sun during eclipses. Those will become ancient relics. The Sun will get too bright. It'll take about 1 billion years for the Sun to raise its luminosity by 10%. This will be devastating for planets in the solar system, and life on Earth won't be possible beyond this point. By then, our species will likely have found a new planetary home. The Sun will swallow the inner planets. In 5 billion years, the Sun will begin to evolve into a red giant, growing hundreds of times its current size. It'll swell up so much, it will eventually engulf Mercury, Venus, and possibly Earth. The new Goldilocks habitable zone may shift to the orbits of Jupiter and Saturn. This process will take a bit under 3 billion years until the Sun reaches its maximum size. After that, our star will shrink into a white dwarf. The most epic event ever. Around the same time our Sun is swelled up, the nearest neighboring galaxy, Andromeda, will come too close to the Milky Way. If we could watch our galactic neighbor at this time, it'll get larger and larger as it approaches. Then, the 2 galaxies will start to merge. Bright blue stars will burst into life. New constellations will form. The 2 spiral galaxies will now be a single giant elliptical one. Wow, I've set an alarm on my smartphone so I don't miss it.
"15,000 years after the construction of the first space colony, planet Kepler 452b, 1,400 light-years from old Earth." Hello, first-year students. We're glad to welcome you to the Intergalactic University. Endless space is now home for us humans, but thousands of years ago, We used to live on just one planet we now call Old Earth. Yes, I understand it's difficult to believe. Today, it's one huge nature reserve. Mammoths and stegosaurs walk on its surface, and pterodactyls fly in its skies. It turned out to be easier to recreate animals that roamed it millions of years ago than to understand how our ancestors lived. The Great Cataclysm made them abandon the planet in a hurry, leaving much of its legacy behind. And now, we're studying it anew. But our excavations leave more questions than answers. Skyscrapers, highways, shopping centers, coffee shops. Everything is buried under sand and soil. Rust has eaten away the metal, and time turns concrete into dust. Even the Hoover Dam and the Three Gorges Dam in China have crumbled. The colossal structures turned into heaps of stones. The remaining buildings have become overgrown with plants and turned into a home for millions of living creatures. But there's good news as well. Faces carved into Mount Rushmore are still visible. The mountain is granite, and this rock is one of the hardest on old Earth. For over 15,000 years, the faces of U.S. presidents have deteriorated by only 2 inches. The monument will stand for millions of years. And the latest expedition to the Sahara Desert managed to dig out the Great Pyramid from the sand. Now any tourist can buy a ticket and look at that wonder, which even Earthlings considered very old. Surprisingly, ruins and crumbling walls of medieval castles in Europe have survived. They're built of massive stones and without metal fittings, which expand and destroy the stone when rusting. Our ancestors left behind a huge amount of garbage. Empty bottles, plastic packaging, wrappers. All this helps scientists to recreate the consumption patterns of people of the past. Thanks to this, we know for sure that in the 2000s, almost 8 billion people ate mostly chips, chocolate bars, and pizza. And they rarely drank ordinary water. They loved coffee, though. 60% of Earthlings lived on the internet for 7 hours a day. 2 billion websites worked 24/7. At first, information was stored on hard disks, flash drives, and compact disks. But this kind of storage went obsolete after a couple of years. The cloud took their place. It was an online storage with servers connected to the global network. They recorded the entire life of Earth's civilization and were stored in data centers. In space, the Earth's internet didn't work well. Apparently, huge distances and lack of technical knowledge did their job. Imagine that a Pluto resident wants to know the difference between margarita and calzone pizzas. They click the link and wait for a couple of hours for it to open. If the dough's already in the oven, no good. Each colony organized its own internet by sending satellites to orbit their planets. It took time to connect thousands of colonies into the intergalactic web we now know as Uninet. When the cataclysm struck, people had to escape, leaving their planet to its fate. Electricity went out, no one maintained the servers and data centers, and lots of info about their civilization was lost. We've scanned miles deep into the Earth and found many interesting artifacts. Students, I invite you to look at this amazing thing. The Earthlings called it a camera. People took pictures of their food, morning runs, and new shoes on it. One thing our scientists couldn't comprehend, though, is that ancient people used to communicate with its help too. One of the main mysteries of the past are the dishes of different sizes. Archaeologists find them in almost every home. They bear these names: Buddy, Cosmo, Rex, Princess. We know these were the things from which dogs and cats ate, but we don't know why people pampered these animals so much. For example, archaeologists recently unearthed a beauty salon for poodles in San Francisco. I also love my dragon from the jungles of Galisa 832C, but I don't perm its fur and manicure its claws. And this is my favorite artifact, a book. There's nothing more valuable in the universe. There's only one sample in my antiques collection. It's a cooking recipes anthology. I paid a fortune for it. The ruins of museums are treasures for archaeologists and all the new humanity. These buildings collapsed a long time ago and now look like ordinary hills, overgrown with trees and grass. Museums are like pearls in the ocean. They lie at the bottom and wait to be fished from their shells. And sometimes, archaeologists manage that. Books, paintings, documents, and clothes have mostly turned to dust. But we can enjoy the statues that were carved out of marble by masters of ancient Greece and Rome. On the walls of caves around the world, there are drawings of animals and handprints of the first people. They didn't know how to read, drive a car, or fly a spaceship, but their paintings have survived. It's incredible. Over thousands of years, time has eaten up huge dams, cities with skyscrapers and bridges, and the palm of an ancient human still adorns the cold and rough wall of a cave. Space archaeology is becoming more and more popular. Thousands of tons of space debris fly around old Earth. The real sensation is the discovery of the Voyager 1 probe. Earthlings sent it into space at the very beginning of their development. I see your condescending smiles. Today, such a device can be assembled by any first-year student from spare parts in their parents' garage. But, dear students, let's not laugh at our ancestors. They tried their best. Voyager isn't a simple satellite. The device can be compared to a message in a bottle thrown into the sea. And the cosmic sea is millions of times larger than the Pacific Ocean of old Earth. Engineers of the past left a time capsule with a message in the probe. It contains photographs of people and the nature of the planet, as well as scientific information about the Earth. 90 minutes of recorded music are of particular interest. This is a real gift from our ancestors to us, to the people of space. Radio signals that humankind sent into space have also survived. We've tracked them. Radio broadcasts, phone conversations, even music charts continue their journey through space. Millions of years later, they'll weaken and leave behind only an electromagnetic echo. In 2020, there were 1.4 billion cars on old Earth. Unbelievable! But they moved along asphalted roads on rubber tires, not in the air. When humans flew into space, they left their vehicles on the planet. Within just a couple hundred years, the cars went completely bust and turned into piles of metal, plastic, and rubber. One that survived for millennia was the lunar roving vehicle. There's no air, no water, and no earthquakes on the moon. Anything that comes here becomes kind of suspended in time, and that's what happened to the rover. Archaeologists have found a lot of other whole and crashed spacecraft on the moon. These devices are priceless artifacts in the Museum of Primitive Earth Technology. In the Svalbard archipelago in the Arctic Ocean, scientists have unearthed the global seed vault. Earthlings built it in 2008. It became a real sensation. The huge silo contained 4.5 million samples of 500 seeds each. Billions of seeds have helped provide agriculture for the colonies. Now you can eat popcorn and hamburgers with real bread rolls thanks to those. For thousands of years, the seeds were kept without human attention. This isn't a miracle, but an accurate scientific calculation. The vault is built underground at a depth of 390 feet. There are no earthquakes or floods there, and the permafrost provided the optimum temperature for the seeds to survive. Most metals are mined from ore. These ores don't contain pure metals, but only their chemical compounds. To get pure iron, the ore must be smelted first. But there's a problem. Metals from ore oxidize on contact with water or oxygen. Simply put, they rust. This is how metal returns to its natural ore state. That's why nails, metal fences, bridges, and houses rust and collapse. But this doesn't happen with gold, silver, and platinum. Things made from these metals are eternal and will never lose their shape. Of course, if you don't start hitting the rings and pennants with a hammer. During excavations, archaeologists find thousands of jewelry items. Earthlings love to wear them on their bodies. Crowns, luxurious necklaces, wedding rings. All this jewelry is now history, kept in galactic museums. The Earth has three main layers: two parts of the core, the dense, hot inner core, and the molten outer core. Then comes the mantle. And then follows the thin crust, the surface that supports life as we know it. At least, that's what we thought, because now scientists found a new mysterious layer located deep within the solid inner core. Earth's inner core is approximately 2/3 the size of the Moon. And made of nickel and solid iron, it's burning hot. The temperature at the center of our planet is the same as at the surface of the Sun. The outer core can reach almost 10,000 degrees Fahrenheit. It's difficult to explore it because we can't go there, and it's like looking through a really dirty window of 3,200 miles of molten metal and rocks. But we can rely on laboratory experiments on heated pressurized rocks, signals from seismic waves, and computer models. When an earthquake hits, it sends out seismic shock waves. Those waves travel through layers at a different speed, depending on the direction they go and the material they move through. In the new study, a team of scientists set a data set of 100,000 deep earthquakes. Some of them went over 60 miles below the surface. When an earthquake happens on one side of our planet, scientists track its waves all along to the other side. Waves change when they come to the other side, so scientists try to understand the materials these waves have passed through. They found a new layer in the core of our planet thanks to earthquakes. Normally, shock waves travel along the equator, but down below, they digress and go into different directions, about 60 degrees to the side. When waves pass through the inner core going from north to south, they will travel more quickly than waves going through the core parallel to the equator. It's important to understand the core because it creates our magnetic field, which, in turn, protects the planet from things like solar winds that are charged particles coming from the sun. In the 1960s, we discovered the Earth pulsates every 26 seconds. It's like clockwork, a giant heartbeat. The ground is slightly shaking, but we mostly don't feel it. Researchers can still track it. Some of them think the continental shelf comes as a huge wave break under the oceans. For example, the highest part of the North American continent falls off into a deep abyssal plain. One theory says waves hit this spot, producing regular pulses. It's like having all kinds of drums. You hit them with your hands and accidentally slam that one spot that produces the right harmonic bang to rattle our entire planet. If this theory is true, we're lucky there are no more spots like this that can shake the Earth. Other scientists believe the pulsation happens because there's a volcano near the critical spot, the island of Sao Tome in the Bight of Boni. You're walking, running, and jumping, but when you stop, it always feels like you're standing still. In reality, you're moving even when you're perfectly still because our planet is always on the move. Depending on where you're at, you could be spinning through the universe at more than 1,000 miles per hour. If you're on the equator, you'll move the fastest. Let's say you have a basketball spinning on your finger. Check the ball's equator. A random point on it has farther to go in just one spin than any point near your finger. That means the point on the equator is moving more quickly. The Earth is a planet that recycles all the time. The ground we're walking on is recycled. Our planet's rock cycle turns rocks of one type into another. That's a cycle that goes on and on. The depths of our planet are filled with magma. As magma is going out onto the surface, it hardens into rock. Tectonic processes like volcanic activity, earthquakes, mountain building, and all of the other processes that shape the surface of our planet bring that rock to the Earth's surface. When the rock is on the surface, erosion shapes it and shaves its bits off. Those small particles then get deposited. All the pressure coming from above compacts the particles into sedimentary rocks, like, for example, sandstone. Sedimentary rocks can also end up deeper and deeper under the Earth's surface. Since there's a lot of heat and pressure, they get cooked into metamorphic rocks. They can go back to the surface once again, or even end up being re-eroded. Sometimes the crust plates are pushing one under another, and this way, rocks can transform into magma once again. explored only 5% of the ocean so far. The ocean itself, as well as life below the seafloor, is still a mystery. The sediments that are underlying our oceans are home to different microorganisms that exist even at depths of 1.5 miles beneath the seafloor. There are microbes hidden deep inside volcanic rocks below the seafloor off of the parts of the Pacific, hidden under 870 feet of sediment. The biosphere under the seafloor is growing extremely slowly compared to life on the surface. Cell division happens every 10 to 1,000 years. Something's different about the Earth's axis. Climate changes and melting glaciers, mostly in the regions like the Himalayas and Alaska, made the axis shift. Our planet has two kinds of poles. Are the south and north magnetic poles. They affect things such as drift and navigation. The axis that the Earth is spinning around is another kind of pole. It shifted a little bit over time, but we don't know exactly why. Researchers realize there are moving masses of water, pushing the Earth's axis eastward. Take a basin of water as an example. If you're moving it back and forth, sloshing makes the water move its weight all around. A similar thing is happening on a planetary level. No matter how large an earthquake is, no human could ever feel an earthquake on the opposite side of the Earth, although some people claim they did. In 2013, there was one near the Kuril Islands with a magnitude of 8.5. It went around 400 miles deep. It was so strong, people in Australia reported they could feel the ground shaking. The strongest earthquake happened in Chile in 1960 with a magnitude of 9.5. The rupture zone stretched from 311 miles to almost 620 miles along the country's coast. Earthquakes with a magnitude of 10 or higher can't happen. The magnitude depends on the length of the fault where it occurs. The longer the fault, the bigger the earthquake. A fault is a break in a part of the planet's crust. It has rocks on both sides, and they move past each other. We haven't found a fault long enough to generate earthquakes with a magnitude of 10 or more. If it happened, it would extend around most of our planet. An earthquake with a magnitude of 12 would require a fault larger than our planet. One side of our planet is getting colder than the other. The Earth has a system that keeps it warm from the inside, a red-hot liquid interior deep below the surface. It spins and, at the same time, generates a magnetic field and gravity. That way, the Earth's core holds the atmosphere closer to the planet's surface. The Earth also absorbs heat from the sun, mostly on the surface. The heat doesn't spread equally on all parts of the Earth. One side of the planet, the Pacific Hemisphere, is losing heat more quickly than another, the African Hemisphere. This happens because land traps more heat than the surface under the ocean. The seafloor is way thinner than the landmass. Also, the temperature caused by the heat coming from inside the Earth is getting lower because of huge amounts of cold water above it. Clouds are not just like some fluffy distant pieces of cotton. They weigh more than 1 million pounds and help regulate our planet's temperature. If you take all the water droplets in clouds and bring them to the surface, you could cover the planet with a liquid layer as thin as a human hair. It doesn't seem like a lot, but this water is crucially important for climate. We'd have warmer temperatures if it weren't for the clouds.
Have you ever wondered how the world will go down in flames? Will it be due to zombies, extraterrestrial civilizations, or AI taking over? Nah, turns out it might actually be mosquitoes and scientists causing the chaos. It's funny how things created by nature aren't as threatening as the stuff that doesn't exist naturally. And you know what's on that list? Editing the DNA genome. Experiments with the genetic structure of living organisms can produce completely new species, and no one knows how nature will react to them. Let's look at an example of gene drive. So it all started with malaria mosquitoes. To somehow stop the growth of their population and prevent the spread of malaria, scientists created a gene that magically made mosquitoes only have male offspring. Several insects with this gene transmitted it to others during the mating season, and thus spread infertility. Scientists were able to stop malaria and destroy almost the entire mosquito population. But imagine if something went wrong in the mosquito genome and their population began to increase exponentially. Malaria could spread across all continents and create huge problems for all of us. Now, let's move from the little mosquito problem to a planetary disaster that can be caused by the desire for knowledge, which is deeply embedded in our nature. British cosmologist Martin Rees once said that we lived in the 1st century when human beings could determine the planet's future. It seems that it's so easy not to destroy yourself, but our nature is quite complicated. In pursuit of solving the mysteries of the universe, we have built a giant machine that, according to some people, may destroy our planet. And this device is the Large Hadron Collider. The main task of this giant machine is to accelerate particles and make them collide with one another. Scientists expect that the collider will help better understand the structure of our universe. In simple words, this is a miniature simulator of the universe. Using it may also shed light on the mystery of dark matter. During operation, the machine compresses atoms and makes them crash into one another at great speed. Perhaps this is how our universe appeared. Some people fear that a small black hole may form because of this collision. A tiny particle with a huge weight will pull all objects inside itself. Its mass will grow, but its size won't change much. As a result, it will compress the entire Earth and turn it into a ball measuring a little more than 300 feet across. At the same time, our planet will still have the same weight. A powerful gravitational pull on such a small area of matter can form a black hole that might later swallow up our entire solar system. There are also theories that the Hadron Collider could open a portal to a parallel universe with creepy monsters that would enter our world. But of course, such theories have little to do with science. Scientists have already launched the collider several times, and as you can see, nothing terrible has happened. But there is a small nuance. With each launch, scientists increase the speed of particles. Who knows what will happen when they accelerate them too much? According to Martin Rees, the probability that Earth will become a black hole is very, very small. Particles with a much larger energy charge fly in space faster than in the Hadron Collider, and nothing catastrophic happens. Okay, now let's go back to our genomic games to see what else can happen if we continue experimenting with nature. The main problem might be an imbalance in ecosystems. In the 19th century, sailors accidentally brought mice to Gough Island in the South Atlantic Ocean. Rodents had no dangerous enemies there, so their population began to grow. Mice began to displace dozens of birds from their home. The rodents attacked the chicks and reduced the population of entire species. Trying to save the birds, scientists decided to get rid of the mice, but these little creatures still managed to survive. As a result, the balance of the whole ecosystem was disrupted. Using gene drive to get rid of one species can lead to uncontrolled population growth of another. Imagine that malaria mosquitoes controlled the population of some flies. And what would happen if these flies lost their main natural enemy? The population of these flies would start destroying other species, and it would begin a chain of destructive events. All this suggests that playing with things that don't exist in nature is very dangerous. We worry a lot about how artificial intelligence can take over the world and eliminate us. Still, at the same time, we don't pay attention to our actions. Genome editing can lead to positive consequences, such as the appearance of healthier people, and destructive ones, like the creation of artificial bacteria that can cause serious health problems. In general, destroying other species is a trait inherent in humans. Because of our actions, many animals have disappeared from the face of the earth. Moreover, we even destroy each other. Such aggressive behavior is our nature. And artificial intelligence doesn't have anthropomorphic properties. Its logic may be completely different from ours, and instead of destroying people, it might strive to save them. And we have something to save us from. Remember the giant asteroid that erased more than half of the living creatures on Earth? The fall of the space rock caused a massive blast wave, a tsunami, earthquakes, and dust clouds that covered the sun. Dinosaurs and other animals couldn't survive in such conditions. But what if something similar happens these days? Fortunately, we're better prepared than dinosaurs. Firstly, we have the technology to track giant meteorites and calculate their trajectory. And artificial intelligence can also help us with this. Secondly, we can destroy an asteroid before it reaches us. Several powerful rockets will quickly deal with any space rock and turn it into cosmic dust. Moreover, we will know in advance about its approach. But suppose that a huge stone the size of dozens of Everests will fly towards us. In that case, humanity should hurry with Mars colonization. But don't worry. Observing the sky shows that large asteroids capable of causing severe damage to our planet are moving in a different direction. The most giant known asteroid that could collide with Earth might do so in 2088. The probability that it will fall on our planet is 1 in 50,000, so you shouldn't have to worry about threats from outer space. What lies in the bowels of our planet is much more dangerous. Millions of tons of magma and hot gases can burst to the surface through destructive volcanic eruptions. More than 70,000 years ago, a large-scale eruption threw a tremendous amount of ash into the air, which then floated in the atmosphere in the form of a giant gray cloud for a long time. As a result, Earth's surface cooled down by several degrees, which led to one of the most massive extinctions in the history of our planet. Some eruptions happen not only inside volcanoes. There's such a thing as flood basalt. A colossal magma bubble accumulates under a vast area and begins to seep through faults in different parts. Magma slowly goes out there for many years and destroys all living things around. And the worst thing about this situation is that we can't do anything about it. Humanity has learned to track meteorites in space, but we're still not good at predicting a volcano's behavior. Even if we find out that some giant rock will wake up in the next 6 months, there's nothing we can do about that. We won't be able to prevent an eruption. All we can do is evacuate people from dangerous territory. We have no protection against earthquakes, and even more so, we can't stop the emission of ash into the atmosphere. It's possible that artificial intelligence will help us with this in the future, but right now, we're powerless. As you can see, there are several options for the end of the world for humanity, and they're all slightly different from those imposed by pop culture and the media. In the end, is it right to look for threats from space or artificial intelligence?